Welcome to video 11 in a series of introductory videos for the CNC programming software. This video's topic is HSS Xpress. HSS Xpress is the 3D toolpath that is included in all of our packages. So even if you have the 2.5D standard package, you still have the ability to do some 3D features using HSS Xpress. So let's take a look at that. So on this part, I'm actually working on the backside here, and I've got a couple of tapered faces here that I need to do some 3D work on. I've actually already roughed them out using my 3D eye machining, something that we saw in video 9 of this series. So I've already machined all that out. Now I need to just finish those faces up. I'm going to use a ball mill to finish those up, and I'm going to use HSS. So I'll just go to add milling operation, HSS, and HSS Xpress is just the linear and constant Z toolpaths you find under parallel cuts, just these two guys right here. The next video, video 12, we'll see what these other options do here. But for this video, HSS Xpress, we're just going to talk about these guys here. So we're going to go with linear to start. And HSS is a surface-based toolpath, meaning that the geometry here is actually a face or a surface that I want to finish. So I'll just go to Drive Surface, New Geometry, and I want to choose the surface I want to finish. In this case, I'll just start with this one right here. Drive Surface Offset allows me to add or subtract material. So if I want to overcut my surface, I can put a negative number. If I want to leave some material behind, I can put a positive number. I'm just going to leave it at 0 because I intend to finish this exact face. Since we're doing linear, I have the ability to tell it which direction I want the linear toolpath to go. In this case, 0 degrees from the X positive axis. If I put in 90 degrees, then it'll almost come out looking like it's from the y-axis. If I put 45 degrees, it'll travel along there at a 45-degree angle from the X positive axis. If I don't know what the actual angle is that I want to go at, I can define the angle by 2 points that form a line. So if I go line, define, it's asking for the start point. So I'll just choose this line or this point right here. Click the green check mark. It's looking for the end point of that line. I'll just go over there and choose the end point of that line. As soon as I have those 2 points, it tells me what angle this is at. And you can actually see that here. It's faded out, but that's actually 270 or 90 from the X positive axis. So you can actually define it by 2 points, or you can actually just plug in the value. In this case, we'll just leave this as is. I usually change this to the second option. So if you see here, the first option in this list is what's represented in the bottom left corner. That blue surface and the red toolpath stays completely within the boundaries of the surface. So this is a good way to limit the travel of the tool. But if I'm using a ball mill, I probably don't care so much about not traveling outside that surface. In our case here, I have nothing I'm going to collide with. So I'm going to set this to the second option, where the red toolpath goes right to the edges. This means that per my tool definition, my tool shape, it's going to try and stay in contact with the surface, but it's not limited by the edges of the surface. I can actually take that ball mill and have the center of the ball mill go right to the edges of the surface. Speaking of tools, let's go and select our tool. So HSS allows me to choose any shape of tool. I can use a ball mill, a bull mill, a taper mill. I can use any shape of tool I want, even actual shape tools, as long as it matches the surface, as long as it can keep a tangent point. In my case here, I'm just going to add a ball mill. We'll stay with the 250, so I'll just accept that. Let's go to levels. Because this is a surface-based toolpath, mainly for finishing, I don't have an upper level or lower level that I have to travel across. I really just have a clearance area, somewhere to retract to or start from inside this toolpath. And you can define those by plane or a cylinder in this case. Cylinder would be centered around either one of these axes or around an axis that I make myself. Plane height is just going to be Z equals 1, and I have my retraction distance and entry and exit safety distances over here. So you have a lot of control over where this enters and exits the part, but there really is no upper level or lower level. We're going right down to the surface. Toolpath parameters allows me to control my step over along that surface. So if I want to leave a good finish, I'm going to change it from 50 thou to 20 thou. But before I do that, I want to point out that you actually, with a ball mill, you have control over the scallop height as well. So if I change that to 20 thou, you'll see the scallop height changes as well. So they're mathematically related based off the shape of the tool. Tool control, nothing really to control here. If you do get into 5-axis work, you'll see that the interface between the 5-axis toolpath and HSS are the same, and that's why there's a tool control section here. Because in the 5-axis version of this toolpath, you actually have control over the angle of the tool. Here, not much of a control, other than what the contact point that the SolidCAM is going to use to maintain contact with that surface. So either the center, the radius, the front, or a user-defined point along our tool. If we go to the link section, we have control over the lead in, lead out, entry and exit. So I can say where I'd like to enter or exit from, and what kind of lead in, lead out I want to use. I actually control in this section here, where I can tell it arcs, normal lines, ramp angles, and so forth. Any kind of 3-dimensional lead in, lead out exists in this section here. All you're doing in the link section is just telling it to use them or not use them. In the links tab, we actually control what happens if there's a gap along the cut or at the end of the surfaces when we link the slices. I'm going to generate the toolpath first, and then we'll see how this comes into play. In the gouge check section, we actually tell it what surfaces on the solid we do not want to machine. So we're gouge checking against those to make sure we don't even touch them. And to do that, I'll just have to enable the gouge check. I can do a gouge check against the holder, the arbor, the tool shaft, and the tool tip. Tool shaft and tool tip are automatically selected as per my settings, mainly because most of the time I'm really just gouge checking against those. But if I were doing a very deep pocket, or I had a shape tool where maybe the arbor might get in the way, I can check those boxes there and do a gouge check against those. We're checking these against the items listed here. So the derived surfaces are the surfaces that I selected in the geometry section. Check surfaces I select down here. I'll say new geometry. And the check surfaces are all the surfaces I do not want to machine. So that's really pretty much anything nearby. I can choose this surface here. I can choose these fillets. Anything that I'm not machining with this toolpath, but I don't want to get machined at all. We actually make it even easier for you with this button here, all faces adjacent to drive surfaces. When I click on that, any surface in contact with the surface that I'm machining is automatically selected. But even if I do that, I might want to select some other surface. In this case, maybe just the bottom of these pockets. That way, if my tool dips too low, it won't actually machine those pockets. And then what our reaction to a gouge would be is below here on the strategy. So there's actually 4 strategies there. Retract tool will retract the tool in whatever direction I dictate in this submenu. Trim and relink surfaces will actually trim out the bit of the code that's causing the collision. So you can see here in this graphic here, the toolpath is going. If it's going to gouge, it just trims that out, and it continues the toolpath as much as it can around the gouge surfaces. Stop tool calculation. Toolpath calculation really just means it'll give me a warning in the middle of the calculation letting me know there's a gouge and I have to do something about it. And then the opposite of that is it'll fully calculate the toolpath and just report the collisions if I choose report collisions. I usually like to use trim and relink, so I'll use that here. Let's just do a save and calculate, and let's take a look at HSS Xpress. So automatically you can see the blue toolpath there is just zigzagging back and forth in the direction I told it to, but it's jumping these gaps by going to the clearance area. You can see there it goes right to the clearance level of Z = 1. So to fix that, I'll go back to the link section, links tab. That is considered a gap along the cut because as the toolpath is going across, it sees that there's a disconnect between the lines. It has to jump to the clearance area. It's considered a large gap. Large and small, the metric for that is basically this number right here. So if it's a larger distance than 20% of the tool diameter, it's considered a large gap. In this case, though, I don't need it to retract to the clearance area, so I'm just going to use one of the other options in this list. I'll use follow surfaces, meaning that it'll follow the curvature of that surface to generate the line. As you can see there, it's continued that line right there, just across there. This is useful if I want to reduce my cycle time so I don't have to retract to the clearance area every time. Or in this particular case, maybe I haven't machined that pocket yet and I just want to finish off that face there just so that everything is smooth for a later purpose. We still have this retraction here though, and that is a link between the slices. And that's happening because this part of the surface is ending and it has to retract just to reposition itself over there. So don't really need to do that either because I'm not really clearing anything. So what I can do is I can say, again, instead of clearance area, follow surfaces. And then now we have a nice smooth toolpath that just zigzags back and forth, keeps the tool down. It's a much more accurate toolpath. So that is linear. Really, the only change you can make with linear is the direction that it goes, but it zigzags back and forth in that direction across whatever selection of surfaces you select. Now let's compare that to constant Z. So constant Z, even though it might look the same as this toolpath that we're about to generate, it actually is doing something completely different. It is now following that surface, but it's dropping down in the Z level with each pass. So for instance, if we go back to toolpath parameters, this is no longer a 20 thou along the surface. This is now a 20 thou in Z as it travels across the surface. You can think of it like a waterline cut. If I were to do it on this surface here, it would go back and forth in this direction. If I were to do it on this surface here, it would just go back and forth along in the same Z plane. Whereas with linear, I can tell it to go that way, or I can tell it to go that way. I can tell it to go up and down. So let's go and change this. I just said constant Z, recalculate, and you can see there's a major difference there. There's much more distance between the passes. If I look at this from the side though, it's still just a drop of 20 thou between those passes in Z. So for this toolpath to make any sense, for it to look any good, I need to actually decrease this a lot. Now it looks similar to what we had before. Even though it's going the same direction, it's a step down of only 5/10, and that along this curvature translates to a step over along the surface of that much. So it's kind of a major difference when you see something this shallow. Normally, constant Z, I would only use it on a purely vertical wall or something that has much more of an acute taper, something that's really just kind of like a 5-degree draft or something. If you have something that's a lot more flat, or if the direction of the surfaces that you're about to select yield themselves a little easier to it, then use linear. But really, between linear and constant Z in the HSS Xpress Toolpath, those are really the only differences. Everything else works the same between the two. Now, I only did that one surface for a reason, because those controls over gaps along the cut, link between slices, if I had chosen both surfaces in the one toolpath, then this gap between them would be considered a gap along the cut. So I wouldn't have the same control I had here where I could say follow surfaces. So in that case, if I want to do the other side and still maintain that smooth toolpath, that good look to it, I'm just going to do a save and copy. And then reselect my geometry. In this case, it's just going to be this face. If I'm reselecting that geometry, I should go back and reselect my gouge surfaces. And I'll just recalculate that one. Again, it comes out to be a nice clean toolpath. Inside the G code, you'll actually see just one movement from here to there. But otherwise, I don't have any issues with gaps along the cut or anything like that. Any questions on this or anything else from SolidCAM, you can always give us a call at 1-866-975-1115, extension 2. You can send us your parts or your questions via the ticket system at solidcamsupport.com. And stay tuned for the rest of the videos in this YouTube channel. Thanks for watching.